Hello, welcome once again to my channel, and this is basically going to be now the continuation of differentiation of trigonometrical functions. To be more specific, we are going to handle parameters, and parameters in this case is a situation whereby we are given two functions. Those are functions of x and y, for example, but in terms of another variable. Now, you already have ideas from the very first introduction of differentiation, but now we are going to basically handle trigonometrical functions. For example, we have been given x as theta equals, x as theta minus sine theta, and y equals 1 minus cos theta. They want us to show that dy dx is cot theta out of 2, and the 2y by dx squared is equals to negative a quarter cosec power 4 theta out of 2. Now, what do we do here? We are basically going to apply what we call the chain rule again. By simply differentiating this function with respect to theta, we also differentiate this function with respect to theta. Then we can now bring in the chain rule. Okay, so what I'm going to do is I'm going to begin with the very first expression here, where we have x as theta minus sine theta. When I differentiate this with respect to theta, it means I will be having dx d theta. I'll be having dx d theta is equals to 1 minus cos of theta. Because when you differentiate sine, you get cos. When you differentiate theta with respect to theta, you get 1. Then I also pick up this function here. We have y is equals to 1 minus cos of theta. It means dy the theta will now be sine theta. Why am I saying sine theta? Because when you differentiate cos, you get a negative, and a negative will give us a positive. When you differentiate the 1, you get 0. So that is when we come up to that level. Then from here, from the chain rule, we shall say dy dx is the same as dy d theta times d theta dx. Times the theta dx, but you remember we have dy d theta already as sine theta times the theta dx. When you get back here, we have dx d theta, but here we want the theta dx, meaning we take the reciprocal. So it means I will have this multiplied by 1 out of 1 minus cos of theta, which gives us, of course, sine theta out of 1 minus cos theta. But remember, they told us to prove that dy dx is cot theta out of 2. So what do? We now need to think in terms of double angles and half angles. But when I look at the answer I have here and the one they require from the question, there is a half angle in the question. So I will think about sine theta in terms of half angles, and also think about cos theta in terms of half angles. So this will basically be 2 sine theta out of 2 cos theta out of 2 divided by, I have 1 here, I will leave it as 1, minus, where there is cos theta, I am going to call it 1 minus 2 sine squared theta out of 2. That is from half angle. So I'll say 1 minus 2 sine squared theta out of 2. Then from there we can do the simplification. Open the bracket, the 1 will cancel, this becomes a positive. Then now we can reduce and see what happens. So from that level we can now say we shall have 2 sine theta out of 2 cos theta out of 2 divided by 2 sine squared theta out of 2. And if we can look at this, we can have the 2 and 2 cancel. Sine theta can reduce with this, so that we remain with cos theta out of 2 divided by sine theta out of 2. And this is the same as cot theta out of 2 that they wanted. So we can now confirm that dy dx is indeed cot theta out of 2. Let us also try to find out the second derivative. Now, when it comes to the second derivative, especially when it comes to parameters, we have a special formula that we use, and it says the 2y by the x squared is equals to derivative with respect to theta, because our theta is the new variable that was given in the question, multiplied by dy dx. I mean, you are differentiating, I beg your pardon here, you are differentiating dy dx with respect to theta. Then after you multiply the expression you obtain by the theta dx. That is something to note carefully. So it means I will say second derivative now is going to be equals to derivative with respect to theta. What are we differentiating? We are differentiating the dy dx, which is cot of theta out of 2. Then after that, we shall multiply the whole of this. We shall multiply the whole of that by our d theta dx. D theta dx, remember our dx d theta was already 1 minus cos theta, but now we want d theta dx. So it means we're going to take the reciprocal. And so I will consider the reciprocal, which is 1 out of 1 minus cos of theta. 1 minus cos of theta. So when I look at this, and I differentiate cot theta out of 2, I first differentiate the angle. And I know when I differentiate the angle, I will get a half. But I know when I differentiate cot, I will get negative cosec squared. So the negative will be reflected there. Then cosec squared, but of course the angle is maintained. Then we simplify this by simply bringing in back the half angles. We have 1 here minus, instead of cos theta, I'm going to say 1 minus 2 sine squared theta out of 2. Sine squared theta out of 2. Then definitely we realize that when we open the brackets, 1 will cancel with 1. The negative and the negative will give us positive 2. So it means I have negative a half cosec squared theta out of 2 times 1 out of 2 sine squared theta out of 2. Then from that level, we can easily see that 1 over sine squared is the same as cosec squared. There is a half here which can multiply by negative a half, so that we have negative a quarter. Now we have cosec squared theta out of 2. Then 1 over sine squared theta out of 2 becomes cosec squared theta out of 2 also. Cosec squared theta out of 2. Now from indices, multiply this by this, you will get cosec power 4. Cosec power, so we shall have negative a quarter cosec power 4 theta out of 2 as our d2 y by dx squared. And this is exactly what they wanted us to prove. And we have done it quite easily. Let us now move on to question 2. Okay, so question 2 says, given that x equals to r cos theta and y equals to r sin theta, show that the 2y by dx squared is negative 1 out of r cosec cubed of theta. We're going to still follow the same steps by beginning with the first function. They gave us x as r cos theta. So I will say the x, the theta, is going to be minus r sin theta. Remember, we are treating r as a constant, and our function we are differentiating is cos theta. So from that level, we can also do the same for y. They gave us y as r sin theta. So we shall be able to get dy d theta. Dy d theta will be r cos theta. R cos theta. Then from that level, we can now go on and get second derivative. I mean the first derivative. That is dy dx. Dy dx is going to be dy d theta by chain rule times d theta dx. And if you can do the substitution, dy d theta, we know it as r cos theta times d theta dx. But remember, we have dx d theta, so we take the reciprocal. So this will be 1 out of negative r sine theta. R and R will cancel, so we remain with cos out of sine, which is going to be cot theta. But remember, we have this minus. That is why it has to remain there. Now that we have dy dx, it means we can now proceed and look for the second derivative. But remember, second derivative in this case has a special formula, which is derivative with respect to theta of the dy dx we have just obtained times all this. We multiply it by the theta dx. We multiply that by the theta dx. What does it mean? It means we are going to differentiate. We are going to be having the derivative with respect to theta of dy dx, which is minus cot theta. And after all this, getting it, we multiply by the theta dx. Remember, the theta dx is 1 again out of negative r sine theta. Out of negative r sine theta. And if that is the case, we shall differentiate this. And we get, because we have a negative here, remember, when you differentiate cot, you get negative cosec squared. So a negative and negative become a positive. And so if this is cosec squared theta, 1 over sine is also cosec theta. So cosec squared theta times cosec theta will give us cosec cubed. So it means the next step will be, second derivative is equals to, we have said this is going to be cosec squared theta, because when you differentiate this with this negative, you will get a positive cosec. Then I can see negative 1 over r, so I can indicate it here. But there is 1 over sine, which is also cosec. 1 over sine, which is also cosec theta. And that leads us to the final answer, which is negative 1 out of r cosec cubed theta. And that is what the question required of us. So you can see that actually there is nothing very new, as long as you understood how to differentiate trigonometrical functions. So this is going to be our last example for this. I'm now going to give you some 2 to 3 questions for you to try out. Okay, so I've only given you some 2 questions here to try out. And the beauty of these questions is that both of them are proofs, so you can easily know whether you passed them or not. Please try it out, and then we meet again in our next episode, and that will be about differentiating inverse trigonometrical functions. Share the video, help out Ugandans out there who are innocent during this COVID time, and let them benefit equally. Thank you, and bye-bye.